So, my name's Aetos, and I'm the head of products for zkPass. And I would like to give a very small demo of what zkPass does and a very quick statement. So, zkPass is essentially a private data oracle. So it works with bridging off-chain private data on-chain, and we utilize state-of-the-art multi-party computation and also zero-knowledge technologies, and to show that the world should only know what you want them to know. And we've raised our 2.5 million seed round around last year, and we've came a long way. We've had over 100 partners integrated with like 20-something chains. And we've minted over 1 million zkSVTs, which is also like attestations. And we're on our way on the second version of mainnet. So, so this is me, obviously, and there's a lot of like private data about me. My name's Aetos. My age is 23, so I was born in 2002, and my nationality is Australia, and also like I have experience working in as a business analyst in the Suncorp, and then slowly working my way into Tencent, which is one of the biggest companies in Asia, and then also I'm working with zkPass. Yeah. So what we can essentially do is we can verify any on-chain and off-chain data sources. So what we can fetch from these data, these platforms, for example, are legal identities, financial data, even like healthcare data, any social interactions and transactions that are happening from, for example, banks, different work experiences from, for example, from LinkedIn, or even like more traditional data sources. Also like certifications, for example, FINRA, or even like just AWS cloud certificates, and a lot of different on-chain and off-chain data. So essentially it's everything on HTTPS, and that's what we essentially do. And so I would like to give a very vague picture. This is essentially the I don't think the laser is working, but essentially the private data market is extremely huge. It's even larger than the public unprotected data, which Chainlink is working towards, and even the smallest part on chain data, this is like extremely small in terms of like the whole landscape, and the concentration of the data sphere is increasing per year. So it's 33 zettabytes previously in 2018, and then slowly working our way up to 175 zettabytes for 2025. So yeah, there's a lot more data than possible and than previously ones. And for example, when you're logging into your website, when you're liking Facebook posts, essentially you're uploading tons of data for different organizations to do a big data analysis with. And essentially what they're doing is they're milking every inch of you, like all the value out of you as a customer. And what we essentially do is we revert the data ownership back to the user. So what we're able to do, for example, in this case, we would want to verify the Binance balance. And so we would have a user ID here, which acts as sort of like a identifier, and also the wallet balance, which is 1,800 USDT. And so if we want to verify any data, what it goes through is, this is a typical life cycle of an attestation. And so zkPass would then generate an attestation out of this data source, and then it would be computed by zkWASM or RISC0 or even Alio zk VMs, and then stored either on-chain or off-chain. So for on-chain, essentially the blockchain, and off-chain there's Arweave or like space and time, Filecoin, and then we also have like centralized databases from a lot of different enterprises. So and then obviously if you want to use that data as a dependency for a lot of different business operations, there's tons of use cases. So essentially what this does, it's 3 simple steps. So the prover and the verifier first join together to secure the TLS connection. So we've utilized the MPC part of this to add a new entity within the TLS connection, so that the MPC node can act as sort of like a witness between the connection to ensure that the connection is the same TLS connection that is used throughout the whole process. And then the prover and the verifier then computes together using a vol-based ZK system. So what this does is essentially is an interactive system. It's not a typical snark, not a Stark. So it's basically 2 parties are computing and sending hashes over to each other to omit a ZK proof at the end, proving that the field does in fact exist within the data source. And then finally, the prover sends the ZK proof back to the blockchain. Or it could be sent to, for example, an AI model with the necessary fields to construct the field or the token, or even to feed the AI models for pre-training or inferencing. So so essentially what this does is it's a 3-party TLS extension. What we've used is the MPC, and then that's pretty much the same. Sorry, I think there's an extra slide, but maybe it's hidden.
Maybe meanwhile I can ask a quick question. So
Sure.
What's the reason that you use vector-only-based proof system? Because it's based on MPC in the head, if I'm not wrong.
Yes, so the reason why we've utilized vol-based is this whole protocol is essentially an extension and improvement of the TLS Notary project from PSD. So what they've done is they've used a snark system before, and that takes about like 2 minutes or even longer to generate a proof. And so what we've done on vol-based IZK is vol essentially enables the circuits to be broken off into smaller instances that can be parallelly computed by a lot of different nodes. So and then after, because it's like vector linked, so you're able to chain them back up together to get that ZK proof.
But I guess you sacrifice the efficiency of verifier, yeah? Because they are linear, I guess, in case of verification.
Yes, but because you're breaking them off into very small pieces, so the utilization rate of the MPC nodes have increased. So that's why so we've pretty much lowered it from 2 minutes into like 2 seconds in like ZK generation, like ZK proof generation time. So yeah, I think there is a slide showing the schemas. No worries. We can circle back. If you guys have any questions, we can also have a chat later after this keynote, and I can show you the the documentations and the tutorials and like the examples that we have.